continue on our unit about conics with parabolas, another conic that you're pretty familiar with. In this lesson, we're going to discuss some of the things that we're probably not really super familiar with, and that's what is the definition of a parabola and how do we apply that to the formulas that we're familiar with. The definition of a parabola is going to involve something that you might not have heard of before. That's going to be the directrix and the focus. So if we had, I'll just do a quick little sketch of a parabola. Before, the things that I really wanted you to be aware of were either the topmost point or the bottommost point of the parabola, and that was the vertex. So the vertex is probably one of the most important parts of the parabola, but we're going to introduce some new concepts and terms. So by definition, a parabola is going to be all of the points that are, if I've got a line right here, let's call that the directrix, and a focus, it's going to be, this parabola is going to be all of the points that are equidistant from this directrix right here. I'll label that as the directrix. And right here is the focus. We need to find all the points that are equidistant between them. So this and this should be equal. This and this should be equal. All of these points, this and this, should be equal. Like this should be equal to this. This should be equal to this. If we've drawn the parabola correctly, all of the points should be equidistant between the focus and the directrix. So we remember how to find our vertex. Our vertex is going to be our h, k value if we're dealing with any of these parabolas. Before, we had the formula y equals a x minus h squared plus k, and this is not really changed too much. We still have our h and k that we're looking at, but you can see that the a has now transformed into this 1 over 4p. What the heck is p? Well, p is going to be this value right here. P is this distance. If I drew out that parabola a little bit better, or give you some more room, P is this distance from our vertex to the focus, or our vertex to the directrix. That's our value for P. So if it's positive, the P should be opening up. If it's negative, it opens down. The same as before with our A value. But the P just allows us to identify where the focus is and where the directrix is. So if we look right here, let's actually plot out our point, our parabola. First off, where's our vertex? Well, our vertex is going to be at the point 5, 3, right? Because we have a y equals 1 over 4p x minus h squared plus k. Well, the minus h is minus 5, so that means our h is 5, and our k is that. So we know that our vertex is at 5, 3. So if I was to plot that out here, 5, 3 is right there. Okay, so what else do we need to know? Well, we're going to need to know our vertex, or sorry, our focus and our directrix. Well, if we've got 1/8, which is our A value, is equal to 1 over 4p, if we did the math, we just cross multiply, we get 4p equals 8. So p equals 2. So to go up to our vertex would be a value of 2, and to go down to our directrix would be a value of 2. So we've got this line right here as our directrix. Here, let me pick a more bright color. That's our directrix. Our focus is right there. And our parabola is going to be, I'm just going to do a light graph of it. These are not completely accurate points, just to show you that it's opening up. So I need to know my vertex. I'm also going to need to know where my focus is, because I'm going up. My focus is going to be higher, so my focus is going to be at the point. I'm just going to go up 2 from our vertex, so it's going to be the same x value, 5, and our y is going to go up 2. And our directrix is going to be this line. So this line has a formula, and since it's gone down 2, it has a y value of 1, so it's just y equals 1 is our directrix. So most important part still is our vertex, and then we'll just determine from our 1 over 4p value in front how far in our focus goes and how far away our directrix is. So let's look at this guy for example 2. Example 2, our vertex is -6, -7. So let's go to -6, -7. He's going to be right there. And let's go with blue again. But what is our p-value? Well, I know that the value in front, -5, equals 1 over 4p. So if I multiply, I cross-multiply both sides by 4p, I get -20p equals 1, and then I divide both sides by -20. I get p equals -1/20. So this is a very tiny value up and down. Big part that I'm interested in is because this is a negative, get rid of that, because this is a negative, it is going down, so it's going to open down. Like that. And my focus is going to be down from here, -1/20. And the directrix is going to be up 1/20. So what is our focus going to be? Well, the x value is going to be the same. Our x value is exactly the same. But our y value, it went down, so it's -7 minus 1/20. It went down an additional 1/20. Our directrix is going to be y equals, before it was -7, it's going to be -7 plus 1/20. We just went up a little bit. Similarly, before we always dealt with our parabolas opening up or down, but even though they're not functions, you can still have parabolas that open right or that open left. Those are going to be, instead of y equals x squared, these are going to be x equals y squared. Now remember, these are not functions of x because they fail that vertical line test. But same things still sort of apply in that we're just going to swap this. So instead of this being our x value and this being our y value, this being our x and this being our y, it's going to swap. So this is going to be our y and this will be our x. So this will go to -3x and our y will go down to -5. Now it's going to open right because this is positive. So I'll just do a very quick graph. Something like that. It's just opening right. And what is our focus? 1 over 1/16 equals 1 over 4p. So if we cross multiply this, we get 4p equals 16. Divide both sides by 4, and you get p equals 4. So that would mean that our focus is 4 in from the vertex, and our directrix is 4 out from the vertex. So what is our focus? Well, our focus is going to be the value of, if you count it out, 1, -5. And our directrix is going to now be, instead of y equals, because this is a parabola that's opening right, because it's an x equals y squared, this is going to be an x equals, so our directrix is going to be x equals -7. That's our directrix. Let's see if we've got any more. Example 4, what is the equation of a parabola whose focus is at 5, 7, and whose directrix is the line x equals -1? So let's just quickly graph this out, just so we kind of get an understanding of what's going on here. So the directrix is the line x equals -1. Well, that's going to be a vertical line, and whose focus is at 5, 7. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So if the directrix is back here, it stands to reason that it's going to open to the right, because our parabola, our focus is going to be inside the parabola, directrix is going to be outside of it. If the distance between -1 and 5, well, that's a distance of 6. Doesn't that have to be split equally between the distance between the directrix and the focus and the directrix and the vertex and the focus? So if the distance between -1 and 5 is 6, that means I would go 3 in, so that I'm halfway between, and that's going to be our vertex. So it's going to look something like that. So our vertex is going to be, well, let's check it out. It's going to be 2, 7. That's half the battle right there. And I know that this distance right here is 3. So 1 over 4 times 3, which our p value would give us an a value, that value that we're going to put in front of our formula of 1/12. So because this is opening to the right, we know it's an x equals y squared. So x equals, let's use a different color. So 1x equals 1 over 12 x, y. Now, got to be careful. We're going to swap our x's and y's. So this is going to be y minus 7 squared plus 2. We used our vertex, and because this is a horizontally opening parabola, we're going to swap the x and the y, so it's going to be y minus our y value for our vertex plus the x value for the vertex, and our value in front is going to still be 1 over 4p. So that's going to be one of the most tricky examples that I can ask you that you wouldn't be necessarily familiar with prior to this lesson. Be familiar with the 1 over 4p, and be familiar with our general translations of graphs from before, and you'll be good.